Hello, my name is CJ, and this is Deep Learning um, Lab 3 video presented by Jeff and I. And basically, Lab 3 focused on implementation of linear regression and uh, logistic regression using deep learning methodologies. Um, part one, uh, part one was to implement linear regression. So in this part, um, we used Wisconsin breast cancer data from UCI machine learning, and we save our data in a data.csv file. And the first task is to read a file. We use the panda and put it in a data frame. So we interested in the data in the second column to 32 column. So first of all, we have to encode our data. So we import the label encoder to encode our labels, or the targets actually. And then we create an instance of label encoder, and then we apply on our y data and transform it. And then we have to split our data into test and training sets. So we used the sklearn training test train split method. The test size is 20% and the training size is 80%. And then we have to transform our training and test data using a standard scalar. And then after scaling or scaling our training and test data, we created a random. We use a random number generator, and we used 42 numbers. And then we have to create a sequential model. So here we apply the deep learning methodologies. That's neural network methodologies. So we created a sequential model and add a fully connected layer, that's the dense layer, of 16 neurons. Activation, we use a rectifier activation. And then our input dimension is 30. Then we also add another layer with 8 neurons, and then with 6 neurons, and then with 1 neuron. We add because we interested in one label. So and then the optimizer we use is Adams with a learning rate of 0.001, and then we have to compile our model using optimizer, that is Adams, and we interested in minimizing the loss. Metrics, we interested in the accuracy of the model. And then after compiling, we have to fit our training data into the model, and we validate using our test data. Batch size, that's the number of inputs we put into each neuron, is 10, and then we're gonna have run it 100 times, and then we have to visualize our data using a Tensorboard. So I will save my logs, my visualized graph into my folder. That's a log. I named this logs slash 1 hot, and then so I printed out the scores of the test scores, and then evaluate my accuracy. And then I also visualize it using I plot a graph of loss versus value loss. That's the training and the test sets. And then I show my graph, and here is my graph. Okay, and that is my graph of the training set. The test set is an orange color, and my training is on blue line. So as we see here, loss, as the number of epochs increases, loss decreases, and that's pretty much it for part 1. And then part 2 is basically on logistic regression. The difference between a logistic and a linear regression is that logistic is more of a binary type. It's more of a binary type in terms of the labels. So here we used the movie review or IMPD data set. That's for the movie review. So we interested in only 4,000. We get 4,000 top words that are used, and then we split into the training and test set, and then we applied it in a neural network. That's a convolutional neural network. So we created an instance of sequential model, and then our first layer of the model is to embed the number of words, is to embed my words. And then I created a one-dimensional convolutional neural network with 32 filters and a kernel size of 3, and activation I use a rectifier. And then I do a max pooling, and then I flatten my data. And then I created fully connected layer of 250 neurons and use a activation rectifier activation. Then I dropped out 20% of my inputs, and then on the other instances of fully connected layers, I use a sigmoid activation. So the sigmoid activation works best for logistic regression. And then here also I'm interested in minimizing the loss using the optimizer as Adam. I'm interested in minimizing the loss and increasing measuring the accuracy. So learning rate of 0.001, that's what I used in my optimizer. Okay, so and then I compile the model and then fit the model using the training data and then validate using the test data. Batch size is 512. I put 512 inputs on each layer. I passed 512. That's the batch size. Gonna run 20 box because it I couldn't use a much higher number because it takes much time processing it. And then I visualized my data using the Tensorboard. So I created an instance of Tensorboard. I saved my graphs on logs. That's where my logs directory is. And then I built evaluate the model. That's put out the accuracy. Plot a graph of loss versus value loss. That's the test versus training set. And then the visualization of these is right here. Taking a while to load. So that's my training set and that's my test set. As we see, the loss decreases as we increase the number of epochs. So right here I got an accuracy of 95. No, that's the IMD. I got a 50% accuracy on the IMDb. That's the movie review set. And on pre-cancer data set from Wisconsin, I got 95.61% accuracy. And to visualize the movie review on a Tensorboard, that's how it looks. So I have my loss, I have my metrics, and then I have dense layers and dropout layers, and then on the scalars or the graphs themselves, let's see what we have. I have my accuracy, that's of 90, almost 96% or 95% max. And then my loss, let's see the loss. As we see, it decreases, and the value loss, that also decreases. So that's pretty much it.